So lower bit quants need less memory and usually run faster, while higher bit quants preserve more quality. And this will automatically choose what it thinks is better based on the balance. So here it thinks that the Qn3 8 billion is a good choice, even though here we have a Q4 quant, because it also check all of the performance of all of these models over the benchmarks, which these are the benchmarks. The next column is one of the most important column, which is a fit VRAM. Full GPU here means the entire model stays in VRAM. The partial, as we saw, means that part of the model spills into system memory. The VRAM column estimate how much memory that configuration actually needs. So it says 5 gigabyte VRAM it needs, and for my system here, which I have 6 gigabyte of GPU, so it says that it will be fully fit into my GPU. The next column is speed. Next comes estimated the generation speed in token per second. So we have a 26 token per second for this model, 27 token per second for another model, the second one on my machine. And here we have several symbols, this one and the question one, this one, and also the color. For the question one, the question mark means that the estimated has a lower confidence because the performance depend heavily on the runtime. So all of these things, these data are static data that they were estimated these data based on the details of my machine. But at the runtime, we may have another performance. This one means that we are pretty much confident about this performance, about this speed. Here the publish is simply the release date, and the score is the overall score that combines the benchmark performance, model size, quantization, speed, memory feed, popularity, benchmark quality, and several other signals. They have it in these tools, in the WhichLLM tools. You can see it, it's open source, so you occasionally see some symbol also here like this one, which means that the score was inherited from the model family. So now here, let's see. So we have also speed here estimated. This one, the low confidence backend sensitive token. You can here see some legends, you know. There's another information here, which is the confidence, the top peak confidence. This one, the confidence about this model here is low for this table. So it says that you cannot be so sure about the performance of this model. So instead of saying trust me, the tool explains how trustworthy the recommendation actually is by considering the benchmark quality, score gap, speed, confidence, and whether the model fully fits in your hardware or not. So you can see all the warning, the speed caution, low confidence speed, the warning about the model 1, the model rank 3, 55% of the line will be offloaded into the CPU. So as you saw it, it's a partial fit model. Once you have used it a couple of times, there's a few also other commands that you can use, and they become surprisingly useful. You have it in this, all of those commands here in this README, and one of it is this one, the -h GPU. So you can say that, pretend that you have this specific GPU. So the tool will pretend to have this GPU, and it will calculate every estimation on that exact table for this kind of GPU. This one simulate a multi GPU workstation. Another one is the speed one. The usable one hides the model that technically run but probably aren't pleasant to use. And also, parameter speed has a usable and fast value to pass. So the usable one technically will show you the models that you can use them, but the fast one is very strict. It only keeps the model that should run and respond quickly. You have also the upgrade comparison, so it will compare all of these models together, all of these GPU together, and it will give you the models and the comparison between the LLMs over all of these GPUs. So for example, I will run this so you can see like this. Here you have a setup, my current GPU, the 5090, and H100. the VRAM, the best models here, the quantization, quality, speed. Another one is hardware planning. This is very cool. This command will tell you that if you want to have this kind of particular model on your system, which kind of GPU you will need. So if you just want to stop thinking about setup, this one works in reverse. Instead of asking what fits your GPU, it asks what GPU fits your model. So you can give them any kind of open model on Hugging Face. You can find them and give the name of it as a parameter to this. You can also run the model directly using WhichLLM. I don't like it. There are pretty more tools for running the LLM, so this feature is kind of side feature. And also this one is pretty cool. So you can use this command to generate the ready to use Python script. So you can copy it and paste it into the code and use the model directly. Here he was saying that I can use this model here, wrong, and here we give me the code, so I can copy and paste this code. It's a Python code with the transformer library. And also you can install this tool with the very different ways. You can use UVX with install it on remote and it won't leave any traces in your device. You can use UV, you can use PyP, you can use pip, you can clone the GitHub, you can do anything you want. You can install this package globally. You can install it only on your project environment. So do it, anything that fits your workstation and your workflow. So the thing I like most about WhichLLM isn't that it's recommend a model. What makes this one different that it's explain why it gives you some technical details in a plain English, so you can see them and understand why which one is much more trustworthy and which one is not. And sometimes the biggest model really is the best choice, and sometimes it's not a good choice actually, like what we saw here. And I think that's far more useful answer than simply saying that download this model and download that model. I will leave the link in the description so you can see it yourself. And thanks for watching.